What is sugar?
A carbohydrate, a molecule composed of only carbon, hydrogen, and oxygen, that tastes sweet. Monosaccharides, or simple sugars, include fructose, galactose, and glucose.
What is alchemy?
Alchemy was among the earliest practices of a chemical science, and, in a way, it can be considered a predecessor to the modern science of chemistry. Alchemy is somewhat different than a modern science, though, in that it also has roots in mythology and spiritualism. Practitioners of alchemy were known as alchemists. Among the primary goals of alchemists were to find a method or material that could convert inexpensive metals into precious gold, as well as to find an elixir of life, which could make a person both youthful and immortal. Myths told of the existence of such materials and of the possibility of such feats. The goals of alchemists were based largely on these myths. In medieval times, alchemists could be found in many countries around the world, and those in different regions held somewhat different beliefs. In the Western world, people were still considering how to make metals into gold as recently as the late 1700s.
What is a polymer?
Polymers are large molecules, usually made up of smaller repeating units. The word itself, polymer, means many parts in Greek. You probably started thinking about plastics, like milk jugs and plastic cups, when you read the title of this chapter. Plastics are common examples, but polymers also play important roles in all plants and animals, including you.
What happens when you fire a wet clay pot in a kiln?
Before the clay is placed in the kiln, it is usually dried in the air for at least several days. This first step has already removed the majority of the water, but there will still be some trapped inside the clay. As it is heated in the kiln, the remaining water will turn to steam as it evaporates from the clay. If it is heated too fast, it may turn to steam while still trapped in the clay and cause the pot to explode. As the pot continues to heat, some of the organic materials in the clay will burn off, which is necessary for the clay to form a strong final structure. The next stage is an interesting one, and to understand it we need to consider the chemical composition of clay. Clay consists of a unit of alumina, Al2O3, and 2 units of silica, SiO2, complexed with 2 molecules of water. So even after all of the excess water has evaporated away, there is still a significant quantity of water that remains chemically bonded within the clay. At this point, water accounts for about 14% of the mass of the clay. As the temperature continues to increase, those remaining water molecules begin to be released. And they too evaporate away. This is another step where the heating must be done slowly. Otherwise, the water can create steam pockets within the clay that will expand and eventually explode. Other changes occur as well, such as changes in the crystalline structure of the silica that will occur multiple times as the pot is heated. Eventually, the glass-making oxides within the clay melt, and the clay will fuse into a ceramic material. The materials that melt relatively easily will tend to fill in remaining empty spaces, strengthening the final product. One final note is that changes in the crystalline structure of the silica will also occur upon cooling. And one must take care to cool the pot sufficiently slowly so that these changes don't cause cracks to develop during cooling.
What is the Charles's law?
A law stating that the volume and temperature of a gas are directly proportional.
Why was gold chosen as a form of currency rather than any other element in the periodic table?
What a neat question. There are very basic attributes to money that made gold the obvious element. The element should be a solid at all temperatures it might encounter over the course of its lifetime. No one wants their money to boil away on a hot day. The element needs to be very stable. We wouldn't want our coins rusting, bursting into flame, or slowly giving off radiation. And finally, the element needs to be rare, but not too rare. After you remove elements that don't fit these parameters, we are left with rhodium, palladium, silver, platinum, and gold. Rhodium and platinum weren't discovered until the 19th century. So they weren't an option for ancient civilizations. The furnaces of the ancient world couldn't reach the temperature required to melt platinum. 3,200 degrees Fahrenheit, 1,800 degrees Celsius, so it couldn't be made into coins. That leaves silver and gold. Gold has a lower melting point than silver and it doesn't tarnish in air like silver does, making it the clear winner for a currency element on our planet.
What is the Nernst equation?
The Nernst equation relates the reduction potential of an electrochemical cell to a standard state reduction potential, along with the temperature, reaction quotient, and number of electrons transferred during the reaction in question. It was first developed by Walther Nernst, who won the Nobel Prize in Chemistry in 1920 for his influential work in physical chemistry.
How much energy is produced from a given amount of coal, oil, or gas?
One ton of coal can produce 6,182 kilowatt-hour of energy. 1 barrel of oil can produce 1,699 kilowatt-hour of energy. 1 cubic foot of gas can produce 0.3 kilowatt-hour of energy. How much does it cost to produce energy from gas? Coal, solar energy, etc. If 1 ton of coal costs $36, which gives an energy cost of $0.006 per kilowatt-hour, and 1 barrel of oil costs $70, which gives an energy cost of 5 cents per kilowatt-hour, and 1 cubic foot of gas costs $0.008, which gives an energy cost of 3 cents per kilowatt-hour, then a 4 kilowatt solar panel system providing energy for an average ranch-style home and costing $25,000 and lasting about 20 years would provide about 120,000 kilowatt-hour for the life of the system, depending on climate, and cost about 21 cents per kilowatt-hour. You can see that solar power is still currently more expensive than other fuel sources.
What's the difference between acetaminophen and ibuprofen?
While the structure of acetaminophen and ibuprofen are very different, the mode of action is similar. Both of these painkillers interfere with the COX family of enzymes we just talked about. Ibuprofen interacts more broadly with members of this family of enzymes, which ends up making it a good painkiller as well as a good anti-inflammatory medication. Acetaminophen binds primarily to one of the members of this family, COX-2, so it's basically just a painkiller.
What does selectivity mean for chemical reactions?
Selectivity can have several meanings for chemical reactions, but there are two main categories. Either a reaction will occur selectively with a particular chemical species or at a particular location in a molecule to avoid unwanted side reactions, or a reaction will produce a particular product selectively.
What are some common units of concentration for a species in solution?
The most common unit of concentration in solution phase chemistry is molarity, or the number of moles of a species present per liter of solution. Recall that the number of moles of a species is equal to the number of molecules of that species divided by Avogadro's number. See History of Chemistry for information on Avogadro's number. In analytical chemistry, it can often be more convenient to discuss concentrations in terms of other units. This is particularly true when the species being studied is present in very small concentrations. Some other commonly used units are parts per million, ppm, parts per billion, or parts per trillion. These units refer to the mass fraction of the analyte in question to total mass of the sample. 1 part per million means 1 millionth, 10 to 6, of a gram of the species in question. Or analyte, per gram of the sample present. Similarly, 1 part per billion means 1 billionth, 10 to 9, of a gram of analyte per gram of sample. And 1 part per trillion means 1 trillionth, 10 to 12, of a gram of analyte per gram of sample. It is also possible to use each of these definitions based on a per unit volume basis, rather than a per unit mass basis, though this is more common in the gas phase. For example, 1 ppm by volume of an analyte means the analyte occupies 1 millionth, 10 to 6, of the total volume of a sample.
How does soap work?
Soap molecules have polar end groups and long hydrophobic tails. In the presence of water, they arrange themselves into spheres called micelles. These structures can transport greasy particles in their interiors, helping remove the bits that water can't remove on its own from your hands or clothes.
What's hair made of?
Keratin is the major component of hair and nails. It's a protein that makes up the outer layer of your skin, your hair, fingernails, and toenails. Actually, keratin is everywhere in the animal world, the hooves, claws, and horns of most mammals, the scales of reptiles, the shells of turtles, and the feathers, beaks, and claws of birds. Many copies of this protein molecule assemble into a large helical structure that provides the structure and rigidity to the material. Keratin proteins contain lots of sulfur atoms in the form of cysteine amino acid residues. These sulfur atoms can form linkages between keratin strands and between the larger helices that are formed, leading ultimately to a curling of the hair strand. Yep, you guessed it, the more disulfide bonds there are, the curlier your hair will be. Hair straighteners work by breaking these disulfide bonds, relaxing the hair to a straight conformation.
How do molecules interact?
The forces molecules exert on each other fall into a few main categories. Van der Waals interactions. Van der Waals interactions are the broadest group of intermolecular interactions. This includes basically all attractive and repulsive forces that don't involve ions, charged atoms or molecules, or the rather unique situation of hydrogen bonding. Van der Waals interactions include forces due to the dipole moments of polar molecules, as well as interactions due to induced dipoles that can form even in nonpolar molecules. Ionic interactions. Another class of intermolecular attractions involves attractive and repulsive forces between pairs of ions, or between ions and neutrally charged atoms or molecules. These interactions are typically stronger than those in the van der Waals category. Interactions between pairs of ions are governed by Coulomb's law, while interactions between ions and neutral molecules are either ion-dipole or ion-induced dipole interactions. Hydrogen bonding. A hydrogen bond is a strong interaction between a hydrogen atom and another electronegative atom. Usually fluorine, oxygen, or nitrogen, that are not covalently bonded to one another. The hydrogen atom also must typically be bonded to an electronegative atom, usually oxygen or nitrogen. The origin of this strong attractive interaction is that a hydrogen atom bonded to an electronegative atom has a partial positive charge due to its lack of electron density. This allows the hydrogen atom to have a strong attractive interaction with electronegative atoms, or ions, which have partial negative charges due to their extra electron density.
What is the greenhouse effect, and how does it affect Earth's temperature?
The greenhouse effect involves the thermal radiation from the Earth's surface being absorbed and re-emitted by gases in the atmosphere, termed greenhouse gases. The re-emitted radiation, much of which is in the infrared region of the spectrum, is sent out in all directions, meaning that some of the energy is sent back down toward the lower atmosphere and the Earth's surface. This results in an overall increase in the surface temperature due to the presence of the greenhouse gases. It should be noted that a certain amount of this greenhouse effect is entirely natural, but the effect can be increased when additional greenhouse gases are introduced into the atmosphere as a result of human activity. As a side note, the name for this effect arises from the fact that greenhouses allow solar radiation to pass through glass and remain inside. In fact, a greenhouse operates on a different principle. The presence of the glass walls in a greenhouse prevent heat from being lost due to convection currents.
What are some applications of thin films?
Thin films are layers of material ranging in thickness from nanometers, 10 to 9 m, to micrometers, 10 to 6 m. They are used commonly for coating optical surfaces and also for coatings on semiconductors. Thin films are used to make mirrors, and these can be finely tuned. In terms of their composition and thickness, to obtain optical surfaces with a wide variety of specific reflection properties, such as wavelength-specific mirrors and two-way mirrors. The ones that are transparent from one side but reflective from the other. Thin films are also very useful for coating semiconductors to tune their conductive properties for different applications.
What is an anion?
An anion is a negatively charged atom or molecule. Anions have a larger number of electrons than protons such that they have a net negative charge.
What chemicals are commonly found in mosquito repellent?
A chemical known as N,N-diethylmethyluamide, more commonly known as DEET, is the most commonly used insect/mosquito repellent. This chemical can be applied directly to the skin to prevent mosquito and other bug bites. It is believed to work because mosquitoes dislike the smell of DEET, so they try to stay away from it. In some cases DEET can be an irritant and, in very rare cases, it has been associated with more serious health problems such as seizures.
What is a kinase?
An enzyme that catalyzes phosphorylation, transfer of a phosphate group.
What about the occipital lobe?
The occipital lobe is in charge of visual perception. It's responsible for processing the information received by our eyes.
What metals are naturally present in biological systems?
Sodium, magnesium, vanadium, chromium, manganese, iron, copper, nickel, cobalt, zinc, molybdenum, and tungsten are all naturally present in varying quantities in biological systems.
What is a bimolecular reaction?
As you might be able to guess if you've read the previous question. A bimolecular reaction involves two reactant molecules undergoing a chemical reaction. They may form a single product molecule, if they combine, or multiple product molecules.
What chemical process leads to the formation of fossils?
There are of course many different types of fossils, but most form through some sort of mineralization process. What's that? In water that has lots of dissolved minerals, after an organism dies. Those minerals can slowly deposit in the tiniest of spaces within that organism, even within cell walls. Well-preserved fossils require the organism to be covered with sediment quickly after death. Like on the bottom of a lake, so that the body doesn't decay before the slower mineralization process can take place.
Why did Paul J. Crutzen, the Netherlands, Mario J. Molina, Mexico/United States, and F. Sherwood Rowland, United States, win the Nobel Prize for Chemistry?
for their work in atmospheric chemistry, particularly concerning the formation and decomposition of ozone. Each of these researchers made important contributions toward understanding how atmospheric ozone is depleted through atmospheric reactions. Importantly, each demonstrated ways in which pollution from humans was responsible for depleting the ozone layer. And they did this by learning how atmospheric pollutants caused the breakdown of ozone. This information will hopefully continue to help us protect the ozone layer and the stability of the Earth's climate.
How fast does light travel?
In a vacuum, the speed of light is about 3x 108 meters per second, which is very fast. That's so fast that a beam of light could travel around the whole world in only about 0.13 seconds. It's interesting to consider just how far away from the Earth stars really are. After the Sun, the next closest star to the Earth is over 4 light-years away. A light-year is the distance light travels in 1 year. This means the next closest star is over 20 trillion miles away. Because light must reach our eyes for us to see anything, if that star exploded, we wouldn't see it until over 4 years after it actually happened.
How does waterproof mascara work?
Like we talked about in the chapters on macroscopic properties and biochemistry. Hydrophobic materials do not dissolve well in water. So it makes sense to make waterproof mascaras from something hydrophobic. Waterproof mascaras contain a combination of waxes to make them resistant to washing off in water.
How did chemists figure this out?
They analyzed fart gas by gas chromatography. No, really.
How do OLED screens work, and what are they made of?
OLEDs, organic light-emitting diodes, are a class of LEDs, light-emitting diodes, in which an organic material emits light when an electric current is applied. These can be used to create television screens, computer monitors, cellular phone screens, etc. An OLED may employ either small organic molecules or polymers. One advantage of OLED screens is that they do not need a backlight, which allows them to be thin and lightweight and also to display deeper black image levels than backlit screens.
What is cisplatin, and how does it help to fight cancer?
Cisplatin is a platinum-based compound, see structure below, that reacts with DNA causing it to cross-link, eventually leading to programmed cell death, also known as apoptosis. Cisplatin was the first in a class of platinum-containing anti-cancer drugs. It has been used to fight several types of cancer and is particularly effective against testicular cancer.
How is nuclear chemistry related to the alchemist's goal of transmutation?
Alchemists sought a way to turn common metals into gold, which we now know is not possible to do in any simple way. The reason is that transmutation would involve converting one element into another, which can't be done by simple chemical processes. It would require a nuclear reaction to take place. Either a heavy nucleus would have to divide into a gold nucleus and another byproduct, or two lighter nuclei would have to combine to form one of gold. Neither of these things happen readily. If early alchemists had recognized the distinction between more ordinary chemical reactions and the nuclear reaction they were looking for, it would likely have saved a lot of time and effort.
What is spectroscopy?
Spectroscopy is a branch of science associated with using light to study transitions between energy levels. Not all scientists who use spectroscopy, spectroscopists, are physical chemists. Though physical chemists, and physicists, are typically the people who develop new spectroscopic methods and experimentally investigate the details of how light interacts with matter. Data collected in spectroscopic experiments is typically presented as some response of an atomic or molecular system as a function of frequency/wavelength or time. When the response is plotted as a function of frequency/wavelength, it is called a spectrum.
What elements are in our food?
Our food is made up of pretty much the same elements that we are. Which makes sense because at some point, the elements in our food literally become the elements in our bodies. We are what we eat.
What are the main classes of biomolecules?
The four main classes of biomolecules are proteins, carbohydrates, lipids, and nucleic acids. Proteins are some of the most diverse biomolecules, and they can perform functions such as protecting the body from pathogens or acting as catalysts for chemical reactions. Carbohydrates can be a source of energy when your body needs it. Lipids include fat molecules and are used for energy storage, as well as to form the membranes that surround each cell. Nucleic acids are what make up our genetic material and store the information that determines a lot about who we are. We'll go into more details about each of these types of biomolecules in the upcoming pages.
What is the freezing point depression?
Decrease in freezing point for a solution from that of a pure solvent.
What is an example of how to green a chemical process?
At the pharmaceutical giant Pfizer, the synthesis of Viagra, see the world around us, originally had an E factor of 105. However, even before Viagra, was made available to the public, a team of researchers at Pfizer re-examined the entire synthesis step by step. Relatively toxic chlorinated solvents were replaced with less toxic alternatives. The synthesis was also modified to recycle the solvents wherever possible. The use of hydrogen peroxide, which carries some associated health hazards, was removed from the process. Another reagent, oxalyl chloride, is also no longer used. Use of this reagent results in the production of carbon monoxide, which is now avoided. In the end, the E factor for synthesis of Viagra, was reduced to only 8, an over 13-fold reduction. Subsequently, similar changes were made to processes throughout Pfizer. The E factor for Lyrica, an anticonvulsant drug, was similarly reduced from an initial value of 86 to now only 9. These sorts of improvements are eliminating millions of tons of chemical waste, while in most cases simultaneously lowering production costs, making safer work conditions, and making products safer for consumers.
What is a centrifuge used for in a chemistry lab?
In chemistry labs, centrifuges are typically used for separating suspensions. A suspension is a heterogeneous mixture containing small solid particles suspended in a liquid. The number of applications in biochemistry and biology laboratories probably far outweighs those in pure synthetic chemistry. Centrifuges are often used to separate the contents of homogenized cellular material to isolate the proteins or cellular organelles. Centrifuges have also found applications in controlling the rates of reactions by simple partitioning of reactants. A centrifuge can be used to separate enzymes from their substrates in solution, which can serve to stop or significantly slow a reaction that is already taking place. In other cases, centrifuges have been used to attempt to accelerate reactions by forcing reactants together at the bottom of the centrifuge tube.
What is rigor mortis?
Rigor mortis is the stiffening of the muscles that occurs shortly after death. Since very little or no ATP is present, muscles are left contracted, stiff, and unable to relax.
What is a bond length?
The distance separating two chemically bonded atoms.
What is the role of photochemical reactions in green chemistry?
Photochemical reactions can often serve as excellent choices for green syntheses. One reason for this is that a photon, unlike chemical catalysts or reagents, leaves behind no waste or excess atoms. Photochemically initiated reactions can often proceed rapidly at ambient temperatures. Since photoexcitation can be used to generate highly reactive species. In some cases, photochemical syntheses can also reach the synthetic target. In fewer steps than those which rely on thermally initiated reactions.
What is the density of a material?
Density is the mass, or weight, of a material divided by a unit of volume. Water, for example, has a density of 1.0 g/cm3, 1.0 gram per cubic centimeter.
What is an orbital?
A possible arrangement for the density of an electron around the nucleus.
What nutrients do plants obtain from the soil?
There are 13 mineral nutrients that plants obtain from the soil. And these are divided into the categories of macronutrients and micronutrients. The primary macronutrients include nitrogen, phosphorus, and potassium. Plants require these primary macronutrients in relatively large quantities and deplete them from the soil more rapidly than others. The secondary macronutrients include calcium, magnesium, and sulfur. Micronutrients are required in smaller quantities than the macronutrients. And these include boron, copper, iron, chloride, molybdenum, manganese, and zinc.
What is a monomer?
If polymer means many parts, a monomer is one part of that whole. A monomer is a molecule that is attached to many copies of itself to make a polymer molecule. Usually these bonds are covalent, but not always.
Can reactions take place in gas, liquid, and solid phases?
Absolutely. Bimolecular, Two species, reactions taking place in the gas phase and in solutions are quite similar in that they involve random diffusion of reactant molecules until they collide, at which point a reaction may take place. For reactions involving solids, the surface of a solid is often reacting with another species that is present at the interface between the solid and a gas or liquid with which it is in contact. An example would be your car rusting to form oxides.
What is an angstrom?
A unit of length used often to describe bond lengths. 1A equals 10 to 10 m.
One might reasonably ask, why does this distinction even matter?
The reason it matters is that if we went to the moon, for example, the weight of an object would change, because the force of gravity on the moon is different from that on Earth. But the mass would be the same, since the object is made of the same amount of stuff. We just need to make sure everyone is talking about the same thing. We should point out that people commonly use scales to measure either weight or mass. But when we're using them to measure mass, the measurement relies on the fact that the scale has been calibrated based on the strength of gravity on the Earth. So it knows how to figure out the mass of an object from measuring its weight.
What is a homogeneous mixture?
A sample containing only one pure substance.
Why did Henri Moissac, France, win the Nobel Prize for Chemistry?
For the investigation and isolation of the element fluorine, and for electric furnace called after him. Moissac was the first to make fluorine gas, F2. Which he did by passing an electric current through a solution of KHF2 in liquid HF. The second part of the committee's statement relates to his work on an electric arc furnace, which he designed to try to make synthetic diamonds.
What are some examples of naturally occurring molecules that affect our biochemistry?
Ascorbic acid, also known as vitamin C, plays an important role in keeping us healthy. It was isolated for the first time in 1932 from citrus fruits, oranges, lemons, limes, grapefruits, and can be synthesized naturally from D-glucose via two distinct biological pathways. The hydroxyl groups allow it to be soluble in water, i.e., in biologically relevant environments, and it is used as a coenzyme in the synthesis of collagen. Benzaldehyde is found in almonds, cherries, apricots, and peach pits. It is often used as an artificial oil of almond. Perhaps not surprisingly, in making perfumes, dyes, and food flavorings. Researchers are also continuing to look into its utility as a pesticide and anti-cancer agent. Benzaldehyde can be readily synthesized in the laboratory using toluene as a precursor. We all know about caffeine. For coffee drinkers, this is probably one of our favorite chemicals. In its pure form, caffeine is just another white crystalline powder. Though most people have probably never seen it that way. It's more commonly found in the cocoa plant, coffee beans, and tea leaves, where people have been consuming it for thousands of years. Historically, people have consumed caffeine to increase their heart rate, body temperature, mental alertness, and attention span. Today, people still use caffeine for most of the same reasons. Caffeine can be extracted using chemical solvents from sources like tea leaves and coffee beans to be used in other caffeinated products like soft drinks. Not to scare you, but it's worth mentioning that caffeine is a potentially addictive substance that stimulates the central nervous system, and if you consume too much at a given time, you may suffer from headaches, irritation, and insomnia. Calanolide A comes from a tree found in the rainforests of Malaysia. It was originally tested as an anti-cancer agent, but was found to be unsuccessful in this regard. However, calanolide A has been found to be very effective in fighting the HIV-1 virus, which causes AIDS. Due to the rarity of this chemical, a synthesis was designed soon after its utility was realized. This drug acts by preventing the transcription of the viral RNA into DNA in a cell, which serves to prevent the HIV virus from replicating. Fortunately, it does this with relatively mild, and temporary, side effects. Dopamine is synthesized in our bodies from an amino acid precursor. It is an important neurotransmitter that balances our feelings of happiness. Imbalances or deficiencies in dopamine production or its regulation have been linked to a number of diseases, including Parkinson's disease, schizophrenia, and Tourette's syndrome. While dopamine was recognized for its role as a neurotransmitter in the 1950s, it took decades of research before its role was more completely understood. The work that led to its connection to the disorders we mentioned, and to an understanding of its exact function, was awarded a Nobel Prize in Physiology or Medicine in the year 2000. An understanding of the role of dopamine in physiology has been extremely important in understanding several neurological diseases. Ethanol is a molecule you are probably familiar with. It's the alcohol found in alcoholic beverages that makes you feel intoxicated, and humans have consumed it for hundreds of years. Additionally, it is useful as a solvent, an antiseptic, a sedative, and a component in perfumes, lacquers, cosmetics, aerosols, antifreeze, and mouthwash. Ethanol can be produced from a raw feedstock, like corn or grain, by fermenting it in the presence of microbes, which can readily digest sugars and produce ethanol as a byproduct. Oxytocin is a hormone produced naturally in females' posterior pituitary glands, which are located at the back of the brain. It is responsible for causing lactation and uterine contractions in pregnant women. Oxytocin is also used to induce labor when a pregnancy does not begin on time naturally. Pyridoxal phosphate is more commonly known as vitamin B6. It helps your nerves and brain to function properly and to maintain the right chemical balances in your body. It is also necessary for the enzymatic reaction that frees up glucose, the sugar monomer, from glycogen, the sugar storage polymer. Vitamin B6 can be obtained from many types of foods including meats, grains, nuts, vegetables, and bananas. Quinine is a molecule that has been used to treat malaria and nighttime leg cramps as well. It was first discovered in South America, in the bark of a type of tree called the cinchona tree, by Spanish explorers, who used it as a medicine. The high demand for quinine eventually led to cinchona trees becoming very hard to find. But thankfully a synthetic method for its production was eventually developed. Succinic acid plays an important role in the Krebs cycle, and can deliver electrons to the electron transport chain. Succinic acid has been found in a very wide range of plant and animal tissues, though its purification challenged chemists for a long time before it was finally successfully purified from tissues. Today succinic acid can be produced readily in the laboratory, and one method even can use corn as a feedstock. In addition to its role in the Krebs cycle, succinic acid has been used as an intermediate in dyes, perfumes, paints, inks, and fibers.
What is a Lewis structure?
Lewis structures are a simple way of depicting the electronic structure of atoms and molecules. They show us which atoms are bonded to each other in a molecule and also show how many non-bonded electrons are present in the valence electron shell of each atom. The easiest way to understand them is probably to just take a look at a few. The simplest Lewis structure is that for a single hydrogen atom, it has just one electron, and its Lewis structure looks like this. The letter H lets us know that it's a hydrogen atom, and the one dot represents its one electron. Here the two Fs let us know there are two fluorine atoms. The line connecting them shows that they are bonded with a single bond, containing two electrons. Each has 6 more electrons surrounding it, and these electrons are non-bonding. And finally for a molecule with more than one bond, CH2O, this molecule is called formaldehyde. The Lewis structure shows us that the carbon is involved in a single bond, sharing 2 electrons with each hydrogen atom, and a double bond, sharing 4 electrons, with the oxygen atom. The oxygen atom also has 4 non-bonding electrons.
Why did Otto Paul Hermann Diels and Kurt Alder, both Federal Republic of Germany, win the Nobel Prize for Chemistry?
For their discovery and development of the diene synthesis. Diels and Alder won the prize for the developing chemical reactions that are broadly relevant in organic synthesis. And they even have a reaction named after them called the Diels-Alder reaction. Dienes are complexes containing a pair of conjugated carbon-carbon double bonds, which can react to form a cyclic product in a wide variety of cases. Further research into this class of reactions has found a tremendous number of applications throughout organic chemistry.
How many stars exist in total?
This is a difficult question to answer, but we can provide a very rough estimate. In our galaxy alone, there are roughly 1011 to 1012 stars. Then consider that there are roughly 1011 to 1012 galaxies in total, and if we assume the other galaxies are similar to ours, this would put the total number of stars in existence somewhere between 1022 to 1024 stars. Clearly there are too many to count.
Peterson, United States, win the Nobel Prize for Chemistry?
For their development and use of molecules with structure-specific interactions of high selectivity. These chemists won the prize for developing/finding molecules that can recognize one another so that they react to form complexes in a highly specific way. They investigated the key features of these molecules that allow for such highly specific molecular recognition. In turn, they produced molecules that can mimic the highly specific recognition features of enzymes. This gave way to the area of research that is today known as host-guest chemistry or supramolecular chemistry.
What is polymorph?
One of the crystalline forms of a substance that can crystallize in multiple forms.
Why do farts stink?
Farts are mostly nitrogen, N2, but that's an odorless gas. The smelly molecules in farts are mostly sulfur-containing compounds that reek like rotten eggs. Other odoriferous compounds include skatole and indole.
Why does asparagus make pee smell weird?
The compounds you smell in your pee after eating asparagus are most likely thioethers. Although the literature over the last 100 years on this subject includes some debate, no joke. That's a sulfur atom with 2 carbon substituents. Asparagus, for some reason, has high levels of sulfur-containing amino acids. Your body breaks these down into chemicals that smell like rotten eggs or other foul odors.
What makes a rubber band stretchy?
Rubber bands are made up of long, tangled up, chain-like molecules called polymers. These long chains prefer to be tangled up because it maximizes their entropy, or just the number of ways they can arrange themselves. See Physical and Theoretical Chemistry for more on entropy, or Polymer Chemistry for more on polymers. When we stretch a rubber band, it straightens out these long chain molecules into a state with less entropy. So basically there are fewer stretched out conformations possible than there are tangled up ones. When we release the rubber band, it contracts to a more disordered state. Primarily just because there are more possible conformations associated with the contracted length.
What is a valence band?
Highest energy range in which electrons are normally present at 0 K.
What is the cerebrum?
The cerebrum is the top part of the brain, and it contains your memories, knowledge, and languages, and it manages your senses as well. The cerebrum is the part of your brain that controls your movements and emotions, and it's where your thoughts take place.
Can elements be converted into one another?
It is possible for atoms of one element to become atoms of another element. One way this can happen is any fission process that results in the loss of one or more protons from a nucleus. The joining of 2 nuclei to form a single, heavier nucleus is also possible, and this process is known as fusion. Both fission and fusion can result in the creation of new atoms with different numbers of protons than were present before the reaction. These processes are often difficult to control in a laboratory, however. So it's mostly only in specific cases, such as energy production, that chemists and scientists in related fields devote a lot of time to these nuclear reactions.
How does a breathalyzer work?
When a person blows into a breathalyzer device, the air they exhale enters a chamber containing 2 glass vials. One is a mixture of aqueous sulfuric acid, silver nitrate, a catalyst, and potassium dichromate. The air is bubbled through this mixture and the sulfuric acid and potassium dichromate react with the alcohol, producing chromium sulfate and other products. The chromium ion of chromium sulfate is green in the solution, whereas the initially present dichromate ion was red/orange in color. The second vial contains the same reactants but doesn't interact with the air sample, thus serving as a standard for comparison. The color change in the sample exposed to the air is monitored by a photocell light sensor system that is then used to determine the alcohol content of the air sample.
What is a plasma?
A phase of matter in which a significant fraction of electrons have been ionized from their nuclei.
What is a bond angle?
The angle relating the orientation of two bonds connecting three atoms.
Why are metals attracted to metal? Or why do magnets stick to your fridge?
Ferromagnets generate their own magnetic field. This means that other paramagnetic substances will be attracted to ferromagnets, just like they are attracted to magnetic fields. Most metals are paramagnetic, so magnets stick to your metal fridge. But your fridge itself is not magnetic.
What is a catalyst?
Any substance that increases the rate of a chemical reaction without being consumed by the reaction.
What is biocatalysis?
Biocatalysis, as the name suggests, involves using enzymes or other natural catalysts to carry out chemical reactions. This tends to work well within the context of green chemistry since biological reactions are often catalyzed in water at mild temperatures and pH values. Moreover, enzymes are themselves environmentally benign and obtained from natural sources. In addition to these benefits, biocatalyzed reactions typically proceed with high selectivity and specificity, and require relatively few synthetic steps, thus minimizing the amount of unwanted byproducts produced. Some examples of biocatalyzed syntheses are those of penicillins, cephalosporins. Another class of antibiotics, and pregabalin, a drug to relieve pain from damaged nerves. The use of biocatalysis is gaining popularity as the necessary technology becomes more readily available and as more people realize the benefits of this approach.
What was the first molecule detected in space?
Hydrogen was probably the first molecule ever detected in outer space. But you're probably thinking of something larger than that. If you exclude diatomic molecules, like H2, N2, O2, etc. Formaldehyde, H2CO, was the first molecule detected in space.
What is the Curie point of a material?
As the temperature of a ferromagnetic material is increased, it can eventually become paramagnetic. See atoms and molecules for a discussion of ferromagnetism and paramagnetism. The temperature above which it becomes paramagnetic is called the Curie point. This is actually also a phase transition, though it's not one that's easy to see with our eyes. Such as when water freezes or evaporates.
What does the city of Miletus have to do with chemistry?
Miletus, one of the Greeks' greatest cities, was located on the western coast of what is now Turkey and was home to where some of the earliest ideas about chemistry were recorded. During the 6th century BCE, the Milesian school of thought was founded. And the musings of three philosophers survived into the modern era, Thales, Anaximander, and Anaximenes. Thales thought the most basic building block of the universe was water and that the earth floated on top of this celestial water. Anaximander challenged both of these ideas, proposing that the universe was born when fire and water, or hot and cold, separated from one another and that the earth simply floated on nothing.
How is rainfall affected by pollutants in the atmosphere?
Air pollution can affect local and global weather patterns, including the amount and frequency of rainfall. At low concentrations, particles floating around in the atmosphere may help clouds and thunderstorms to develop. But as their concentration increases, these same particles can inhibit the formation of clouds that give rise to rainfall and thunderstorms. This topic is also relevant to issues surrounding climate change. Since clouds are understood to generally have a cooling effect on the climate because they reflect incoming sunlight.
What is meta?
Term used to describe two substituents on an aromatic ring that are separated by one position. I.e., 1,3 substituted.
How do nuclei spontaneously decay?
Nuclei can undergo several types of decay through spontaneous means without colliding or interacting with nuclei of other atoms. The most common types of nuclear decay are called alpha radiation, beta radiation, and gamma radiation. These differ by the type of fragmentation the nucleus undergoes during the decay process.
What is bronze?
Bronze is an alloy of copper and tin that may contain up to 1/3 tin. Early civilizations used bronze because it could make stronger, more durable tools than stone or pure copper.
What is an adiabatic process?
An adiabatic process is a process in which no heat is exchanged with the surroundings.
What was the first organic chemical ever synthesized in a lab?
Plus urea. In 1828 Friedrich Wöhler was trying to make ammonium cyanate, NH4CNO, but this salt turned out to be unstable. It reacted to form urea, demonstrating for the first time, arguable according to some, that an organic chemical could be made from inorganic starting materials.
What causes dandruff?
Despite what you may have heard, dandruff is actually not caused by dry skin but rather by a specific type of fungus or yeast. While dandruff does cause flaky scales of skin to shed off of the top of a person's head, dandruff is actually due to the interplay between yeast organisms and natural oil glands. Unfortunately, there is no genuine cure for dandruff, but it can be controlled by using special shampoos containing zinc pyrithione, selenium sulfide, coal tar, or ketoconazole. To be effective, these products typically need to remain on the skin for several minutes before being washed away. In fact, the scalp is not the only place that dandruff can occur. Dandruff can also manifest on a person's eyebrows, mustache, and beard area, as well as the ears and the nose.
What is the partial pressure of a species in a gas?
If you have a rigid container containing a mixture of gases, the partial pressure of a species is simply the pressure the gas would have if that one species occupied the entire volume of the container.
What is the temperature in outer space?
There is not actually a single uniform temperature for all of outer space, it tends to be warmer at least in a relative sense, in areas that are closer to stars or planets. On average, though, the temperature is only about 3 Kelvin, which is about minus 270 degrees Celsius. It is extremely cold in outer space, so we humans would not last long floating around in the far reaches of space. Even if we could breathe there, which we can't.
What is an E factor?
The E factor is a metric of how environmentally friendly, or harmful, a chemical process is. Specifically, the E factor is the ratio of kilograms of waste generated per kilogram of product synthesized. Thus, the lower the E factor, the more environmentally benign a process should be. Of course, this is only a single metric, and other factors, like the toxicity of the waste produced, should also be taken into account. In pharmaceutical companies, the E factor for the synthesis of drug products is typically in the range of about 25 to 100.